Okay, let's talk about how you monitor load on a Linux server. Um, let's actually start by looking at how you can view processes on the server. That would probably be a good way to start. So, we can view processes using the command ps. Now, ps by itself shows us very little information, but it does give us a couple of things. So, we have the process ID, that's that first column under PID. We have the TTY, which shows us which terminal we're connected to. The time is not how long it's been running, it's actually how much processor time it's used. And then we see the command. Now, when we just run ps, it shows us our processes. So to view more information, let's do the command psa. Now, this is going to give us a bunch of different things. You'll notice that I have a bunch of things show up here that didn't before. I also now have a status field and a command. So first thing is the command field is going to tell me the actual command. And you'll see here I'm running nano on a background session. I'm running nano with the etc password file. I'm running htop, cron tab. So a handful of different things that are going on in the system. Now the A is showing me things for all users, sort of. It's for all users, and it gives me the full command information. But to identify a command with a user, I do ps au. And that's going to show me the username right here. And this now becomes my first column. So this is going to tell me that a couple of these things are actually root processes. And then a couple of more of these are my processes. And you'll see under the TTY column now, you'll see some things that are in under TTY1 and some things under TTY2, which is my second connection to the system. The point is just that it's giving you more information, including understanding what user is running the processes. Now, if I want to view all processes, including background processes, I do the ps aux. So the A gives me more information for all users, the U tells me which user, and the X shows me processes that aren't associated with a particular terminal. And so you're going to see those, and I wish I could move my mouse over to see it, but you see, let me do it this way. Let me pipe that through more real quick. And under the TTY, you'll see everything with a TTY question mark. All right, that's something that's not associated with a particular terminal. And so this is showing me even more information. Now, it's also going to show me, let me come back up here again, my process ID, my percent CPU usage, and my percent memory usage. All right, so that could be useful if I want to look at what processes are using the most memory or the most processor time. And this is something we do quite a bit when we're trying to monitor processes. So this is how it would work. It would be PSAUX. And then I want to do dash dash sort. And that's going to sort it by whatever. And so I'm going to do equals. Now this is going to be a little weird. It's equals minus P CPU. So what that does is that says sort all of this by negative CPU or CPU in descending order. If I do pCPU without doing the negative, it's going to show it in ascending order. And so down here at the bottom, you see is where we have 0.06, 0.02, 0.01, and then everything else is zeros. By doing the negative pCPU, let me go ahead and pipe that to more for a second. It's going to show it to me in descending order. All right, so that's kind of useful because now it'll give me which processes are using the most CPU, and it's going to list them at the top. Now there is another thing I can do here. Let's say I only wanted to see, I didn't want to see everything, just show me the top 10. So there we'd pipe it to a command called head and say dash n10, or header is the very top, and show me the first 10 lines. And that gives me just those first 10 lines of my CPU usage, or percent CPU usage, which is probably the most useful. Now, I could also do this for memory. So I'm going to change my pCPU to pmem. Who's using, what are the top 10 users of memory in my system? And now you'll see these processes along with their command and their associated process ID. Now, process ID is what we could use if we wanted to kill a runaway process or something like that. All right, let me clear this. There's a couple of more things. So we've looked at processes. We looked at our running processes, who's using what. Now, a couple of more things we want to look at. Let's take a look at our total free memory. So that's going to be free. Now, this actually displays in kilobytes. Maybe megabytes is actually going to be a little bit easier way to look at it. So if I look at it this way, my system has 3,921 megabytes, or 4 gig. We've used 3.2 gig of it, and we have 5.15 free. Now, some of this is actually going to be used by my buffer and my cache, and that's the next one over. So we've got free, shared, buff, cache, and available. Now, the available is what is currently not being used for anything at the moment. And typically, if you leave a system alone, it will take and start using some of that available memory for its buffer and cache. And that's to speed up access when you do request something from it. So what we actually have available or free for software to use is going to be in that free category, not in that favorable or available category. Get the right word there. So if you see available is pretty low, don't panic. Look at the free, and that tells me on this system with 4 gigs, I've got half a gig that's not being used for anything. Or that's available to software. It is technically being used, some of it, for the buffer and the cache, but it is available if I need it. So I can do the same thing, by the way, in gigabytes, free-g, although that really doesn't, I mean, it's really not usable in most situations. Megabytes is the one that I think is probably going to be the most beneficial. And one other thing we want to look at, and that is CPU load. So when I did ps-aux, it showed me all of my processes and how much time they had used. Let me do that again through the filter more. It showed me how much CPU time they had used, and that's that last command before column, and then the percentage of CPU time that they've used. Okay. But how can I tell what my CPU load is overall? Well, what we're looking for is something called load, and a fast way to find it is using the command uptime. Now, uptime is going to give me a bunch of information. First off, how long the system's been up. Now, this is a virtual machine, and I just fired it up a few minutes ago, so it's been up for a total of 14 minutes. We have 2 users, me and, well, from another session, me. And then you have the load average, 0.06, 0.03, 0.03. All right, those 3 numbers represent the average load for the last minute, last 5 minutes, and last 15 minutes in order. So, what should be a good load average? Well, that depends. Your load average, if your load average is equivalent to the number of your CPU cores. Now in this case, I have 1 processor core. It's a virtual machine, that's all I've dedicated to it. So if my load average was 1, it would mean that on average I had 1 process waiting for that CPU, or being served by the CPU at any given moment. On average. If my load average is higher than my total number of cores, then I probably have a problem because I have things backing up waiting for that CPU queue. If it's less, then my CPU has available time. A lot of times it's not actually doing anything. You can see, I mean, right here, this thing is doing nothing. So when you're looking at load average, you want to compare it to the total number of processor cores that you have. If the load average is higher, you might have a problem with your CPUs being overworked, and your CPU is going to become a bottleneck. If it's lower, then your CPUs are not your bottleneck. Okay, so that should give us some ideas of how we can monitor processes and system load.